Assalamu alaikum everyone. My name is Abdullah Haider. Today I will be explaining chapter 10 of the course Differential Equations and Linear Algebra. So this is the last chapter of the course, and some people consider it to be the hardest chapter, but inshallah I'll try my best to make this the easiest chapter so that you can get full in the final inshallah. So رب اشرح لي صدري ويسر لي أمري واحلل عقدة من لساني يفقهوا قولي رب زدني علما. Okay, so when we say that we want to make find the Laplace of a function, basically we're turning a function f of t we're transforming it into another function f of s. So basically this is your original function and this is the Laplace of that function, and we will be using the definition of the Laplace to solve this first question. So one thing you need to know is Laplace is written as this kind of L. You need to use this kind of L to denote the Laplace of something. So the Laplace of f of t is the integral from 0 to infinity e power minus st f of t d of t. And usually you will not be asked to use the definition, but in case there comes like one question where you have to use this definition to find the Laplace of any function, then you have to use it. Otherwise, you can use this table of Laplace transforms. This table will be given in all exams, and it has the Laplace for literally everything. There is extremely less memorization in this chapter, so hopefully that's a good thing. So we want to find the Laplace transform for f of t is equals to 1. So what we can say is Laplace of 1 is equals to 0 to infinity e power minus st, and f of t is 1, so it means times 1 is e power st d of t. So basically now what you do is you integrate. So once you integrate, you will get minus e power minus st over negative s plus c, but usually in this chapter you can assume that there will not be any constant of integration. So basically this is your this is basically how you integrate, and then you apply the limits infinity 0. So when you apply so when this goes to infinity, basically you know that 1 over e power st. So basically the exponential graph looks something like it's basically a decreasing function. So it's like approaches 0 when you go to infinity. So you can say that in this case you will have 0 minus, and then you substitute 0 in place of t. So 0 minus e power minus s 0 over minus s means plus means e power minus 0 over minus s. Oh no, this minus will get cancelled out. So minus means the minus gets cancelled out, and this will give you 1 over s. So now you can say that the Laplace of 1 is 1 over s, and if you want to verify this, you can simply go here see where you have 1. Laplace of 1 is 1 over s, so our answer is correct. And not only for f of t is equals to 1, you can be asked about anything. Laplace of t, Laplace of e power t, Laplace of cosine, Laplace of sine, all this. But just a simple example to show how you can apply this integration to find any Laplace. Now, if I want to find the Laplace transform of t squared minus 3t minus 2e power t sine 3t, what I'll do is simply Laplace of t squared minus, now you can take out the constants, minus 3 Laplace of t minus, you can take out the constant again, Laplace of e power minus t sine 3t. And now simply you can use the table, it will be provided. So Laplace of t squared. Now if we go to the table, t squared basically means you're looking for something which is t power n. So you have t power n here. And don't look at this. This is something else. A warning that we will not be using t power a. This is something related to gamma functions, but this is not included in the material you need to know. So something like t squared means you're looking at t power n and you'll be using this. So in our case, n was 2. You have t power 2 means 2 factorial or over s2 plus 1. So 2 factorial over s power 2 plus 1. This is our Laplace of t squared minus 3. Now we need to find the Laplace of t. It's 1 over s squared. 3 times 1 over s squared minus 2 e power minus t sine. Now you find where is e power minus t sine. Yeah. So in this case, we'll be using this Laplace, which is e power minus. So in this case, you have e power minus t sine 3t. So in this case, when you compare a and your k, so in this case, you have a is minus 1, k, you'll be using this one, yeah. So here a is minus 1, here k is 3. So basically, we will be substituting our answer here. So k3 means 3 over s minus a squared. So s minus minus 1 is s plus 1 squared. S plus 1 squared plus k squared means plus 9. No need for this bracket. And now you can simply just simplify. So you get 2 over s power 3 minus 3 over s squared minus 6 over s plus 1 squared plus 9. And this is your final answer. This is your final answer for the Laplace transform of this function. Now we want to find the Laplace transform of 3e power 2t plus 2 sine square e power 3t. Same idea. You will be finding the Laplace of 3, Laplace of e power 2t plus 2, the Laplace sine square 3t. Now important note, in this table, you will not have sine squared equal, you will not have any sine squared property over here. You will not have a sine squared property here. So what you can do is, sine squared of sine squared x is the same as 1 minus cosine 2x over 2. You should know this property from, I think, calculus 1 or calculus 2, I'm not sure. So in this case, when you're dealing with sine squared 3t, you should get 1 minus cosine, this will be doubled, so 1 minus cosine 60 over 2. So now we want to find the Laplace transform of e power 2t plus 2, Laplace transform of 1 minus cosine 60 over 2. So first we'll find the Laplace of e power 2t. E power 2t means you will look at this function. E power 2t, you have a is equals to 2, means the answer should be 1 over s minus 2. So 3 multiplied by 1 over s minus 2, so 3 over s minus 2 plus 2. Now we can split this Laplace, basically. The Laplace of 1 over 2 minus cosine 60 over 2. So Laplace of any constant, Laplace of any constant is going to be divided by s. So in this case, this 1 over 2 will become 1 over 2s minus now this cosine 60. Cosine, we have cosine 60 over there means k is 6, so s over s squared plus 36. S over s squared plus 36, and this is multiplied by 2. So in the end, our answer is going to be 3 over s minus 2 plus, you can keep the 2 out. 2, 1 over 2s minus s over 2 s squared plus 36. This is your final Laplace. This is basically your final answer. You can multiply by 2 inside if you want. So as I did for these two parts, you can use this table to find the Laplace transform very easily. Now, what if I want to find the inverse Laplace? So basically, what this means is we're going from we're reversing the transformation from a Laplace function back to our f of t, and then you can simply use the table. Determine the inverse Laplace transform of f of s is equal to 1 over s plus 2. So you're basically looking for something which has 1 over s plus or minus whatever. So let me first reset everything. So you're looking for something which has 1 over s minus or plus. So nothing on the left side, nothing here. You have this. You have 1 over s plus 2. This matches what we have over here. So in this case, if you want a 1 over s plus 2, this means that our a should be minus 2, and this means our final answer is e power minus 2t. So, and if you want to denote the inverse, you can simply use the same L, but with negative 1 here. So inverse Laplace of 1 over s plus 2 is basically what we found here. 1 over s minus a is negative 2. If you make it a negative 2, then you'll get 1 over s plus 2, and e power minus 2t. E power minus 2t. This is your inverse Laplace of this function, this f of s. And same goes for this. We want to find the inverse Laplace of 2 over s squared plus 9. You look for something. So basically, one thing you need to know is s is a variable. In the chapter, you need to know that s is a variable and k is a constant. So not to get confused with anything. So k is a constant any number. So in this case, we're looking for something which has k over s squared plus k squared. We need to find a k over s squared plus k squared in our table based on what we have in our question. So k over s squared plus k squared. When we look at the table, you have this k over s squared plus k squared, and this belongs to sine kt. So meaning inverse of such a function should be sine kt. But there's one important trick here. Here, the k above and below won't match. Basically, you cannot have. So basically, in this case, you have k is equals to 2 and k is equals to 3. But there is something you need to be aware of in this part. So what will you do is you give the priority to the denominator. You give the priority to the denominator, basically. Meaning, in the end, whatever is in the numerator, it always has to be k is equals to 3. So whenever you have a situation where you have a different k on the numerator and in the denominator, you focus more on the denominator. So basically, s squared plus 3 squared. Hence your k is going to be 3. And what you will do is, you will write it as it is, 3 over s squared plus 3 squared. But we have a 2 here. Now how to get this 2? We can simply write 2 over 3 multiplied by 3 over s squared plus like s squared plus 3 squared. So why am I saying this is so that you do not get confused about which k to pick. So you have k equals to 2 here. Here you'll have k to 3. You give priority to k over k is equals to 3, and you write it as it is, based on the correct k, which is 3 over s squared plus 3 squared. 3 squared is 9. But in the end, you still need to correct your answer to the final. You need to correct your answer based on what you have in the question. So if I want to have a 2 here, I'll multiply this by 2 over 3. Means now I will take the Laplace inverse of this. And if you have a constant, you can take out the constant and find the Laplace inverse of 3 over s squared plus 3 squared. So you'll have 2 over 3. Now in that case, since you have the correct case here, sine 3t in that case. Sine 3t, 2 over 3 sine 3t. And if you want to check your answer, if you want to check your answer, what you can do is now you can take now this is your final answer. This is your final answer. If you want to check your answer, you can simply just find the Laplace of your answer, basically. So sine 3t means you substitute 3 over s squared plus 3 squared, means this should be 9. And then you multiply this by 2 over 3. So 2 over 3 means the 3 cancel out. So you'll have 2 over s squared plus 9, which is what you have in your question. Okay. And now we will move on to initial value problems of Laplace. So this is where this is basically the beginning of where the fun starts in this chapter. And whenever you have an initial value problem means you have initial conditions and you have this equation given. So what you will do is you will take the Laplace of both sides. Laplace of both sides. So you need to take the Laplace of both sides means you will take Laplace of this, and then you'll also take Laplace of 0, but in this case, Laplace of 0, you need to know this. Laplace of 0 is 0. Basically, it means if you take the Laplace of 0, you get 0, so you can keep it as it is. And now you take the Laplace of each of these variables separately. So we'll take the Laplace of x double prime minus the Laplace of x prime minus 6. Always take out the constant when you're finding the Laplace, minus the Laplace of x is equals to, now if you take the Laplace of 0, basically this will simply give you 0. So the Laplace of x double prime, Laplace of x double prime means, one thing, one note is if you have x double prime of t or f double prime of t or y double prime of t, they basically mean the same thing. So meaning that even though we might have x double prime here, we'll use our f double prime of t. Basically, they basically mean the same thing. So if I have x prime, f prime, y prime of t, they basically mean the same thing. So nothing to get confused about this. It's simply that we're writing it in terms of x. So we need to find the Laplace of x double prime, means we'll go here. F double prime of t is s square f, but instead of f, we will be simply using, and it's better to keep this in closed brackets. I'll tell you why. So x squared. Now, one important thing you need to know is you can notice that this f is capital and these are the smaller letters. So basically, this is capital F. This is small f. This is small f. So same applies here. S squared big X. S squared big X. So x squared big X minus to make this more visible. So s squared big, if you have a big half here, means you have a big X over there, minus s. So let me just make it more simple. S squared big X minus s small x of 0 minus small x prime of 0. Now you notice that there's a difference between the big X and the small x, but just write it for now. S squared big X minus s x of 0 minus x prime of 0. Keep this in separate. Now we found the Laplace of this. Now we need to find the Laplace of x prime. X prime is the same as f prime of t, means, and then again, pay attention to the capital. In this case, you have s big X minus, and this means small x of 0. So then again, you do it like this: S big X minus small x of 0 minus small x of 0 and minus, and now the Laplace of x is so basically the Laplace of x in this case, you have capital F of S means you'll have a big X here is equals to 0. Now, what is the purpose of this initial value problem is we want to write our left side of this left side of our equation in terms of S over whatever we have and take the inverse Laplace. So our goal is to first what we'll do is substitute so in this case we'll substitute our initial conditions in the second step. After you take the Laplace of each of these variables separately, you will substitute the initial conditions immediately. So you have so you found the Laplace of x double prime leads you to this. Laplace of x prime leads you to this. Laplace of the small x by itself leads you to 6 minus 6 big X. And now we will first substitute our initial conditions. In this case, we will have s squared x. This x has nothing to do with our initial conditions, minus s. Now what is our x of 0? 2 minus x prime of 0 minus 1. Close this bracket, minus s big X minus now x of 0 again. 2 minus 6x is equals to 0. And now simplify this. X squared big X. You need to know the distinction between the big X and small x. So minus 2s plus 1 minus s big X minus 2 minus 6 big X, and try to like simplify this further. S squared big X. Now take all the x's, all the big x's to the left side. S squared big X minus s big X minus 6 big X, and now leave everything else to the right side. So minus 2s. So 1 minus 2 means minus 1 is equals to 0. Yeah. So now our goal is to keep everything which has x on the left, keep everything which has x on the left side and take the rest to the right side. So meaning s squared big X minus s big X minus 6 big X is equal to, now take the remaining whatever which does not have the big X on the right side. So 1 plus 2s. Open up next space. And now we will factor out our big X from here. So as I said before, once you take the Laplace and you substitute the initial conditions, your goal is to only have the big X on the left side. So x s squared minus s minus 6 is equals to 1 plus 2s. So in this case, your big X is going to be 1 plus 2s over s squared minus s minus 6. And we have entered the uncharted territory of this chapter, which is having a partial fraction on the right side. We need to take partial fractions on the right side. And a small note, the biggest enemy of chapter 10 is going to be partial fractions. I'm not lying. If you can solve 100 questions on this chapter, but only understand 20% of the chapter only because of these partial fractions. Trust me, these are going to be your main enemy in this whole chapter, dealing with partial fractions. So x is equals sorry, big X is equals to 1 plus 2s over s squared minus s minus 6. And let me check if something is wrong. Oh, this should be plus. Minus means plus, so minus plus 1 plus 2, this should be 3. Should be positive 3. My bad, to be honest. And should be negative 3, and this should be negative 3. Yeah, you need to like pay attention to this as well. 2s minus 3. Now what you will do is you will take the inverse Laplace, but you can only take the inverse Laplace if you have a proper fraction. So basically, what you have is you have your big X of s, and you need to transform this to your X of t, meaning you need to take the inverse Laplace of both sides. Now, if I take I take the inverse Laplace of both sides, means I'll have small x is equals to inverse Laplace of 2s minus 3 over s squared minus s minus 6. Now you can only take the inverse. You can only take the inverse if your fraction is proper. But in this case, if you literally look in the table, you have nothing which is related to 2s minus 3 over. So basically, there's nothing related to the table about. You have nothing you can compare to this in the table. So what we'll do is we will split this into partial fractions like you did in calculus 2. 2s minus 3 over s squared minus s minus 6 is equals to a over now. How can you factor this? S plus 2, s minus 3, I think. 1 minute. Yeah. So you have a over s plus 2 plus b over s minus 3. This is how so basically you factor them into two separate binomials, and you should remember from calculus 2 that you will basically be doing cross multiplication. So instead of s squared minus s minus 6, you can write s plus 2 s minus 3. Now you cross multiply, you get 2s minus 3 is equals to a s minus 3 plus b over bs minus 2. Now there are many ways you can solve partial fractions, and in each way I will like talk about. So basically you will not always have you not have such a simple partial fraction like this. As I go along the chapter, I'll teach you different ways of finding these constants A and B, because this is basically the main battle of the chapter, finding the constants in the partial fractions and moving forward. So in calculus 2, you might have learned something which is basically using one of the rules of these answers to find partial fractions. So like if I use s equals to 3, meaning a3 minus 3 will cancel out, and then you can find b easily. So a3 minus 3 plus b 3 minus 2 is equals to now 2 times 3 6 minus 3 is 3. 3 is equals to now 3 minus 3 is 0, so 0 is 0 plus b 1. So in this case, you have your b is equals to 3. You have your b, and then again, and then you can use, now you can use s is equals to 2 to like cancel this out so that you can find your a. So 2 times 2, 4. 4 minus 3 is 1. 1 is equals to a. 2 minus 3 plus 0. 2 minus 2 is 0. So 1 is equals to a minus 1. So in this case, your a is negative 1. Space. Let's see how we can do this. So now you can basically say that imagine forgetting how to write the last yeah, the Laplace inverse of this fraction 2s minus 3 over s squared minus s minus 6 is basically the Laplace inverse of, now a is minus 1 over s plus 2 plus b 3 over s minus 3. So now you're dealing with something which has s 1 over s plus 2 or 1 over s minus something. So you go here, you look something which is relevant to 1 over s minus plus, and you'll realize that you can use this again. So this is equals to minus 1 over s plus 2. So minus 1 over s plus 2. Your a is minus 2 means a is equals to minus 2. And you take out the negative sign from outside, so minus e power minus 2t. Minus e power minus 2t. And now now this part is done. Now you 3 over s minus 3. 3 over s minus 3. In this case, a is equals to 3. So in this case, when you take out the 3 and 3 multiplied by 1 over s minus 3, so 3e power 3t minus e power minus 2t plus 3e power 3t. I think I've done a mistake again. So this is basically so this will be 2s minus 3 is equals to a s minus 3 plus b s plus 2. So now there are many methods of finding these constants a, because in calculus 2 you might have only learned basically like doing s is equals to 3 and s is equals to minus 2, basically trying to make one of these 0. You can do this here, and but the problem is you will not have kind of these kind of simple partial fractions to do. So there are like more than one method to do to solve partial fractions for finding a and b. For now, I will just explain the calculus 2 method, which is making one of these constants 0 by making like s minus 3 is equals to 0 or s plus 2 is equals to 0. So if I use s is equals to 3, I'll get 2 times 3, 6 minus 3 is 3 is equals to a. 3 minus 3 means a equals to 0 plus b 3 plus 2. So 3 is equals to 5b. Your b is equals to 3 over 5. This is your b. And if now substitute s equals to negative 2. So minus 2, not minus 4 minus 3 minus 7 is equals to. Now if you substitute negative 2, you get this 0. A minus 2 minus 3 minus 7 is equals to a minus 5. So in this case, your a is 7 over 5. And now you found your a means your your Laplace of the fraction 2s minus 3 over s plus 2 s minus 3 is equals to the Laplace inverse of, now a we have 7 over 5. 7 over 5. And it's better to keep them separate. 7 over 5 times 1 over s plus 2 plus, now what was your b? 3 over 5. 3 over 5 multiplied by 1 over s minus 3. So we need to find the Laplace. So basically the Laplace of 1 over s plus 2 and Laplace inverse of 1 over s plus 2 and Laplace inverse of 1 over s minus 3. So you go back to the table. You see where you have matching. So in this case, you'll be using these two. 1 over s plus 2 means your a is negative 2, hence e power minus 2t. So this is equals to 7 over 5 e power minus 2t plus Now 3 over 5 times 1 over s minus 3. We have 1 over s minus 3 in this case. Your a is 3, so e power 3t. That's 3 over 5 e power 3t. This is your final answer. Final answer. All right. And that's it for this question. So then again, small recap. You take the Laplace of both sides, Laplace of each of these variables separately. And when you've done that, you apply the initial conditions immediately. And you try to take these x's, this x to the left side, and take everything else to the right side. And you write it in terms of x is equals to and whatever you have left. And as you can see, this is an improper fraction. We need to convert this to our partial fractions so that we can take our inverse Laplace easily. You can use the calculus 2 method, which is basically trying to cancel out one of the constants so that you can find another one. Once you've done that, you take the Laplace inverse of both sides, Laplace inverse of x, of this big X, which is basically the small x, Laplace inverse of the simpler fractions, and that's what you get. Now this was easy because you have a 0 here, but of course you will not be expecting a 0 in the exam, so let's look into this question. So you have x double prime plus 4x is equal to sine 3t. Same principle, you take the Laplace of the Laplace of both sides. So Laplace of x double prime. I will not be wasting too much time on this question. But for the Laplace of x is equals to now the Laplace of sine 3t. So Laplace of x squared, once again, you go back to the table. So in this case, you should have s squared big X minus s of small x of 0 minus x prime of 0. So s squared big X minus s x of 0 minus x prime of 0. And x means basically x by itself is the big X plus 4 big X. And now the Laplace of sine 3t. You go to sine 3t, you have, this is your property, means you have k is equal to 3. In this case, you'd have 3 over s squared plus 9. 3 over s squared plus 9. So you substitute the initial conditions now. Substitute the initial conditions. S squared big X minus s, now x0 is 0, minus x prime of 0 is 0, plus 4 big X is equals to 3 over s squared plus 9. So in this case, s squared big X minus 0 plus 4x, not k, x big X, or big X is equals to 3 over s squared plus 9. Now, as I said before, you factor out the big X, so x squared plus 4 is equals to 3 over s squared plus 9. And hence, your big X is going to be 3 over s squared plus 4, s squared plus 9. And you will notice that something is odd about this question. You have basically s squared plus 4, and these cannot be factored. All right, so now we need to do inverse Laplace on both sides. But before we can do that, we need to convert this into partial fractions. So we can write this as 3 over s squared plus 4 squared plus 9 is equals. Now, you might remember in calculus 2, if the degree the degree of the highest degree of the denominator is like 2, so it will be as plus b over squared plus 4 plus cs plus d over s squared plus 9. So basically, like in the previous example, we had something like 1 over s minus 3. So in that case, you'll have only an a. But if you have 1 over s squared plus 4, and the fact that this cannot be factored. S squared plus 4 cannot be factored. S squared plus 9 cannot be factored. So in this case, you have to write an expression which is like ax plus b. Similarly, if you have 1 over s cubed plus 7, then you have ax squared plus bx plus c. This is literally all the calculus 2 stuff. So let me first erase this. So in this case, we get 3 is equals to as plus b multiplied by s squared plus 9 plus cs plus d s squared plus 4. So now now you can expand actually. Now you can expand. 3 is equals to as cube plus 9as plus bs squared plus 9b in brackets plus cs cube plus 4cs plus ds squared plus 4d. Now, what you can do is basically check the color first. Now, what you can do is now this is another method to find the partial fraction. So here what we did was we basically find the s's which makes canceling the constants easier. But in this case, it's like first of all, it's not possible since x squared plus 4 cannot be 0, s squared plus 9 cannot be 0. So our only option is to compare the degree of coefficients in both sides. So what I mean by that is you can basically write this as you can combine them. A plus c s cubed plus now b and d, b plus d s squared plus now 9a 9as 4cs plus, so in this case you get 9a plus 4c multiplied by x and 9b plus 4d. Yeah. So basically what you're doing is you're grouping them based on so basically grouping them based on similar s power 3, s power 2, s and whatever. And what you will do now is you'll equate this to 0 You'll equate this to 0, you'll equate this to 0, but equate this to 3. You'll make this equal to 3 because this is a constant. We have a constant here. We don't have an s cube. We don't have an s cube on the left side. We don't have an s square on the left side. We don't have an s on the left side. So all these will be equated to 0. But this will be equated to 3 because 9b plus 4d is a constant, and constant equals to constants. So what I can say from here, a plus c is equals to 0. b plus d is equals to 0. 9a plus 4c is equals to 0. 9b plus 4d is equals to 3. So from this we can get c is equals to negative a, and here 9a 9a minus 4a is equals to 0. So 5a is equals to 0 means a is equals to 0. So this is the first thing you get. Then you can say here d is equals to minus b, and here 9b minus 4b minus 4b is equals to 3. 5b is equals to 3 means b is equals to 3 over 5. We've got our b, and since c is equals to negative a also means that c is equals to 0. D is equals to negative b means d is minus 3 over 5. We've got all our constants. We've got all our constants. So now we can find our Laplace inverse. So you can first say, keep getting this wrong. Laplace inverse of this 3 over s squared plus 4 s squared plus 9 is equals to now a is 0, c is 0. A is 0, c is 0. So b over s squared plus 4, 3 over 5. Well, basically, yeah, c over 5 times 1 over s squared plus 4 plus d over s squared plus 9. So d, so it should be minus, by the way. Minus 3 over 5 multiplied by 1 over s squared plus 9. And here, basically, we're finding the Laplace inverse of this. Laplace inverse of this bracket. And if you open the table of Laplace transforms, we're looking for 1 over s squared plus 4, 1 over some s squared something. And let me first clear this. Yeah. So s squared plus 4, 1 over s squared plus k squared means, so if you have 1 over s squared plus 4 means have k over s squared plus k squared. So in this case, our k is 2. We're dealing with sine kt. But know that we have our from here our k is going to be 2, but here our k is going to be 1. So as I said before, you write as it is 2 over s squared plus 2 squared. But since you have a 1, you can do 1 over 2 times, and then the Laplace inverse of this is going to be 1 over 2 sine 2t. So 3 over 5, 1 over, multiplied by 1 over 2 sine 2t minus 3 over 5 multiplied by, and I think it's going to be the same concept. It's going to be the same idea. We have 1 over s squared plus 9. Should delete this as well. We have 1 over s squared plus 9. Based on this, our k is equals to 3. So 3 over s squared plus 3 squared. But we have a 1 here. So what we'll do is 1 over 3 multiplied by means canceling 3 of 3 and 3 to get 1 over s squared. 1 over s squared plus 9 squared, and this will be sine 3t. So 1 over 3 sine 3t. So your final answer is going to be x is equals to 3 over 10 sine 2t minus 3 over 15 sine 3t. And that is your final answer. So just to give a quick summary, you take the Laplace separately of each variable and Laplace of both sides. You substitute the initial conditions, and you get an equation in terms of x is equals to whatever you have on the right side. And since you have an s power 2 here, we will have as plus b and cs plus d. Find the constants, find all of the constants by equating each similar exponent of s, and then you find the inverse of the 1 over s squared plus k squared based on the table. And remember that if the k in the numerator and the denominator don't match, then rewrite the transform based on the correct k and multiply by whatever is needed to get the correct fraction. So this is done, and now I think there's something different in this initial value problem. So as I said before, you need to take the Laplace of both sides. You'll take the Laplace on both sides. Laplace of x double prime plus 6 Laplace of x prime plus 34 Laplace of x is equals to 0. Laplace of 0 is 0. And this will be based on this table of Laplace transform. This will be s squared big X minus s small x of 0 minus x prime of 0 plus s big X minus s of 0, s big x minus s x of 0, or basically oh yeah, There is no s here, so this will only be x of 0. I need to check something above. Did I do any mistake here? Yeah, I'm fine. Minus x of 0 should be a 6 here as well. That's 34. This should be the big X. Is equals to 0, and just substitute the initial conditions. So s squared big X minus s, now x0 is 3, minus x minus 0 is 1, plus 6 s big X minus 3 plus 34 big X is equals to 0. So give me s squared big X minus 3s minus 1 plus 6 big X minus 18 plus 34x is equals to 0. Group all the big X's together. S squared big X plus 6s x plus 34 x. At this point, just factor it out already. Don't want to consume a lot of time. So x multiplied by these numbers minus 3s minus 3s minus 1 minus 18 minus 19 is equals to 0. We can double confirm. Yeah. So you take this to the right side and divide by then you take minus cs minus 19 to the right side and divide by s squared plus 6x plus 34. In this case, your final big X is going to be cs plus 19 over s squared plus 6s plus 34. And now we need to find the partial fraction. I'll teach you a different method in this. I'll teach you a different method in this example. So this 3s plus 19. So what you can actually do here is you can do complete the square, meaning that if you have s squared plus 6s plus 34, you can write this as s plus 3 squared plus 25. Now, how you can do this? Assume you don't know how to complete the square, although you should. What you do is you write s plus, now this number divided by 2, which is 3 square. And so basically, what you do is you do s plus the middle number over 2 inside the bracket and square it. So in this case, you get s squared plus s squared plus 6s plus 9. You compare this and you compare s squared plus 6x plus 34 and x squared plus 6x plus 9. The thing missing is 25. So this is how you can complete the square basically. So based on this method, you can write s plus 3 squared plus 25. And what you can also do is, I'll erase this part. It's up to you, whichever method you want. It's like up to you, whichever method you want to make things easier. You can use partial fractions or completing the square. But I can also write this now as 3 s plus 3. So 3s plus 9. I have the remaining, I have 10 over s plus 3 squared plus 25. So basically what I want is I want to get an s plus 3 in the numerator so that I can cancel it out and make things much easier. If you don't understand how to do this, I'll give one more example. Let's say I'll give it in a future question. Okay, let's see. For now, let's deal with this. So I can now write this as 3s plus 3 over s plus 3 square plus 25 plus 10 over s plus 3 squared plus 25. So what you can do is, if you consider this portion only, and you go to the table of Laplace transforms. Look here. We have I'm not able to write on that page, unfortunately. I don't know what's wrong. So we have s plus 3 over s plus 3 squared plus 25, meaning I have an s minus a over s minus a squared plus k squared. I'm not right on this. Yeah, that works. So I have s plus 3 over s plus 3 squared plus 25. Plus minus doesn't matter. And this can be written as 5 squared. So in this case, we can use e power at cosine kt. So in this case, your a is -3, and your k is 5. So e power minus 3t cosine 5t. So when I want to, so basically, if I want to find the inverse Laplace of 3s plus 19 over s squared plus 6s plus 34. So it will be the inverse Laplace of this function, which is e power minus 3t cosine 5t, 3e power minus 3t cosine 5t. And now for this one, we have 10 over, we basically have 10 over s plus 3 squared plus 25. And we have a constant here. This time we have a constant. So in reality, we can use this one. To be honest, you really need some practice on knowing which formulas to use. But I'm just saying is now you can convert this to 2 multiplied by 5 over s plus 3 squared plus 5 squared. Why? Because our k in this part is k is equals to 5, and if we are to use this formula, we need 5 on top here. So s minus a squared plus k squared means 5 should be here, 5 should be here. So that is why I have a 5 squared here, and I have a 5 here, and I can keep the 2 outside so that I can use this formula properly. So k is 5 and a is -3 still. So I can say it's e power minus 3t sine 5t. So this will become finally plus 2 e power minus 3t sine 5t. This is the final answer. And a simple note that not always, not 100% times, this completing the square method works. In my opinion, partial fractions is still better. I can understand that this partial fractions is looking really long, and you might like literally go with this method for every question, but to be honest, I really don't advise, because sometimes it does not work. Because what if what if you really cannot complete the square? What if you really cannot complete the square? You might have some difficulties. It's up to you, to be honest. I always go with a partial fraction method because even though it might be long, it's safer to use. In case you get stuck on completing a square, or you find that late in the later steps you really cannot find something which matches the functions here, then that's why it's safer to use Laplace. And I think I can say that this is the end of 10.3.